Haven't done a new M2 build video in a while, so I'm going to try something a little bit different today. This is an Intel build for the NCase M2. Welcome to Machines More. NCase M2, wonderful small form factor case to work with and build in. We'll do an inverted mATX build with this one today. One of the strengths of this case is the ability to take a micro-ATX motherboard, and compared to a mini-ITX motherboard that you might typically use in a case of this volume, you can either get more features, which is mainly what we'll see with this board today, or it can also come in at a better price, which I'll show you in another upcoming M2 AM5 build. And sometimes it is a combination of both. Either way, there is an advantage over mini-ITX board. I don't do many Intel builds. The latest Core Ultra 2 generation hasn't been as strong as many would have hoped, but I have warmed up to the CPUs a little bit. As an example, when I first tested out the 265K that I'm using in this build today, I was disappointed that the gaming performance wasn't the strongest, but lately that pricing has dropped to a very attractive level. This CPU is competitive against the 9900X for multi-threaded stuff, and it beats it in certain applications. It is an 8 performance core plus 12E core. It's a serious multi-core setup, and now it's coming in at a much better price. So one application for a 265K build could be one where you want to use it as a rendering or video editing workstation. And it's not like it's terrible for gaming, and especially in situations like 4K gaming, the difference versus something like the 9800X really won't be as stark, and you have a lot more multi-core performance versus that chip. To pair the CPU, this is the ROG B860G. It is the only Strix mATX board, and it only comes in white, so perhaps a silver M2 would have been better suited, but the black is what I have here. The board features the B860 chipset, so it will not allow for manual CPU overclocking. Overall, the board has a very high-end feel with 14 power stages, 80 amp power stages for the CPU V-core. The biggest drawback versus Z890 is that with the Z890 boards, you can apply Intel's new Core 200S overclocking profile. Even if you didn't want to manually overclocking, that can have a significant impact on your performance. I do hope they slowly or somehow roll this feature out to B860 boards as well. There are Z890 mATX boards. I haven't checked it out yet, but Gigabyte's Aorus Elite seems like a reasonable alternative, albeit the power delivery is weaker there. There's also an Asus Prime Z890, but that, for that board, other than the chipset, it is in fact more basic in features. So while this one is only a B860, this board does have higher end features, and it looks incredible. I think they just nailed it with the appearance of this board. Features I appreciate here, instead of a whole bunch of expansion slots that you may not be using in an SFF build like this, you get 3 additional M.2 slots. They are Gen 4 compatible. The topmost one is housed in its own heatsink. That one is a Gen 5 compatible one. Just make sure you put your Gen 5 drive there, and the other ones for your additional drives. And I like this heatsink assembly with the quick release lever. Got 2 24GB sticks of Clev's 7200 MHz DDR5 here. With these CPUs, you could go even faster. It's just a matter of how much you're willing to pay for the kit, but this is a good balance of price and speed here. Power supply here is Asus's ROG Loki 850-watt SFX-L unit. Very high-end ATX 3.0 unit, well equipped for the 5080 that we're using in this build. The stock cables with this feel very nice, and they are supple, easy to manage up. Since we are doing this one as an inverted build, it is going to attach right above the M2's front I/O plate. When you position the power supply this way, this SFX-L unit does not interfere with the GPU's length, so you can have all the way back if you need. To cool the CPU, I am using Asus's Prime 240mm AIO. Normally with micro-ATX builds in the M2, you may have the option to mount the radiator at the top if you're not doing it as an inverted build. Unlike with mini-ITX builds, you can't just shift the board away though, so that the components from the board don't interfere with the radiator. Here, with a setup, the RAM is too tall. Sometimes a tall board heatsink like this will also be a problem. But since this isn't inverted built anyway, none of that makes any sense. That radiator would end up at the bottom where it wouldn't get much airflow. So we will just be side mounting this one like I have here. One upgrade I did here is swap out the stock fan. which is a dual fan combined single plate unit. I'm doing this build with two Fantex T30s. You have the clearance here for these excellent fans. They will maximize the cooling as well as run at a gentler noise profile versus most stock AIO fans. For this example, I went ahead and repurposed the stock fans as the case fans. If you listen carefully, these, like many stock AIO fans, have a little bit of a clicking sound that you can even pick out at low RPMs. So if you are sensitive to noise, you should put in something nicer like Noctua NFA 12x25s or Be Quiet Silent Wings 4. For this example, but I'm just sticking with them. The graphics card here is ASUS's Prime 5080 OC. At this point in time, the selection and pricing still is not great for 50 series or AMD 90 series cards. So your choice of card may hinge on what you can ultimately obtain. That aside, this Prime unit is an excellent 5080 that doesn't have too thick of a cooler assembly. It's perfect for small form factor builds. It features a vapor chamber, which you can see clearly from the side. And form factor wise, a very good choice for the M2. Pretty good temps with this one, despite the slimmer form factor here. And inverting the case lets us get good airflow to the card. With mini-itx boards, you do have the flexibility in the NCase M2 to shift the board so that you can position the card directly against the outer panel. Micro-ATX, we don't have that flexibility, so by reusing the stock AIO fans here or just putting case fans here, that bridges the gap and we don't have to run these very fast either. I'll set a fan curve that tops out at 800 RPM or so, and at this point they don't add perceivable noise to the system. One optional thing that you can do if you're willing to use the Armory Crate software is index the fan to the GPU temp so that it can scale along with GPU usage. But there are other fan utilities that you can use as well. One quick note here is that I've positioned the radiator fans as side intakes, and that is a good way to maximize the CPU performance without impacting the GPU temps too much. The card does have the case fans directly assisting it, and the airflow will balance out by the radiator and GPU's exhaust exiting out the back, as well as the opposite side panel of the case. Let's go ahead and take a look at some benchmarks. For Cinebench R23, the CPU temps hovered around 80. This was a repeated extended run here. Fans were at around 1600 RPM here, so there is plenty of headroom left here with the Fantex T30s, which top out at 2000 RPM if you set them to performance mode. At this temp, the P cores are hitting 5.2 gigahertz consistently, as they should, and the E cores are 4.6 gigahertz, so all good. And that score of 36K, that's a really solid performance. In this scenario, the total system draws down around 280 watts, and that's a good estimate for CPU-heavy rendering. One thing, these Core Ultra Series 2 chips are great on idle power draw, and for this system, the idle power draw I measured was averaged 60 watts for the whole system. For gaming, using Cyberpunk 2077 1440p as an example with ultra settings and ray tracing as at ultra settings, a DLSS on here, temps are very good here. The system draws down 460 watts at these settings. With DLSS off, at these ultra settings, you will not be able to hit 60 FPS. In fact, most systems won't. This level of settings will necessitate DLSS on. There's no need for any frame gen, and you can get very playable and an enjoyable experience here with the upsampling. As mentioned, this would also be an incredible system for video editing, and running the DaVinci Resolve Studio benchmark, excellent performance for the 265K in conjunction with this 5080. For MSFS testing 2020 here, the frame rates are good, although if this or other CPU limited titles are of interest to you or that's your priority, this is where an AMD CPU with that 3D cache excels. But to get the higher end productivity performance, then you'd need to step to a 9900X 3D, which is going to run you a lot more than the 265K, or the 9950X 3D, which is a lot more, but it's also a lot more powerful than the 265K for productivity stuff. Finally, for gaming, Monster Hunter Wilds, this is a fairly decent score here at 1440p and ultra settings. Here's a quick sound sample for your gaming noise level and CPU rendering, just a reference here. Overall, this is an excellent system with solid components where you want both productivity and you still want to do some gaming. The 265K is very competitive for multi-core applications. After all, the difference between this and the 285K is just 4 E-cores. But it comes in significantly cheaper, and that will free up some of the budget to spring for a higher end graphics card. I'm going to be doing another mATX build in this case next week before I head out to Computex in Taipei. That one's going to be a little bit more budget minded, but it's still going to be quite powerful. So please make sure you subscribe, stay connected. Go ahead and give a like if you enjoyed this build. Component links are down below. Big thanks for watching today.